Welcome to the breakdown for the problem-solving investigation task for 11 apps, which is focusing on statistics. So, let's have a look. Problem-solving task, 30%. It is due on the 8th of October, so next term. So, yes. All the normal stuff to be marked on concepts and techniques and reasoning communication. All that stuff is the normal stuff. Basically, make sure you say, this is my own work, I promise no one else did it for me. I have a copy just in case things get lost. Since you're submitting it digitally, that shouldn't be an issue. Good advice is before you try to submit it, email it to yourself, because therefore you will always have a copy of it. Or email it to yourself. So, the objective of this assignment is a number of things. Design and implement a real-life experiment. So you're going to collect the data. You're going to decide what to collect data on, and then you're going to collect it. You need to then conduct the experiment to produce the data. You need to perform the appropriate analysis of measure of center and measure of spread. And then you got to write up a small report. So to summarize, you need to decide what you want to collect data on, collect the data, analyze the data, and then report on the data. That's the assignment summarized down, and that'll get broken up into more detail. So, important things to make note. You need to get approval from your teacher on your topic before you start collecting the data. And that's mostly to make sure that you're collecting data on the right thing. What's really important is you need to collect 2 categories of numerical data. If you try to just collect categorical data, this assignment will not work. So you need to put a proposal forward just so that so your teacher can say, yes, that will work, go for it. Or, oh no, that's not going to work, how about this instead? It's not about trying to stop you from having fun. It's mostly trying to make sure you can actually do the assignment. So, talk to your teacher about the topic that you want to do. It's recommended the experiment is able to be performed easily with minimum cost, without the need of special equipment. I mean, if you have the special equipment, fine, then use it. But if you need to measure, the speed of sound at different sort of altitudes or something, that's not going to work because that's a lot of technical sort of equipment. Keep it simple. It is a requirement that the data collected has 2 clear categories and a minimum of 30 numerical values in each group. The example report at the end is to be used as a guideline of how to format your report so you can know how to set it out and how to respond. And you should only really veer away from that outline with a really good reason. Project proposal must be submitted and approved by your teacher. It must include statement of objectives, listing the variables you're going to measure. So if you say, I'm going to throw paper airplanes, then my question is going to be, well, what are you measuring? And if you say, how far the plane flies, I'm going to say, cool, what unit of measurement are you using? And then you'll say, I'm measuring with meters I'm going to be measuring in meters with 2 decimal places. And I go, excellent. So you've got to be really specific with what units of measurements you're using for this task. There's a template down below for the project proposal. Just copy the headings from the form and just fill it in. There's a template for the report as well. You will submit this on Sector. Please submit it as a PDF. And yeah, there's a guide. So, your assignment is broken up into these things. Statement of the objectives. Description of the procedure. Statement of objectives is, what do you want to find out? Description of the procedure. How are you going to collect it? Data collection. So basically, just list the raw data. Presentation and tabulation of the data. So organize it into a table. Analyze it. So measures of center, measure of spread. Inferences, conclusions, recognitions of limitations, recommendations. So basically, based upon your data, what do you think? Like, what have you found? Tell me about it. Basically, if I was only going to reach a conclusion, that needs to explain everything that happened. And this is the important stuff. And then if I really want to, I can go back and have a look at your data and go, oh, really cool, this is nicely done. Further application of, basically, is there a good application this could be used for? Maybe yes, maybe no. I don't know. It depends on what your objective is. And then you get marked on the overall presentation. Is it easy to read? Is it, formatted nicely? And originality. Mostly, if I get 30 people who all want to measure how far 2 paper airplanes fly, that's going to be rather dull. So, make it interesting. If you are stuck, I can make some suggestions. And then you can use those as inspiration to figure something else out. So here's the template. On your template, this is what you need to do. Your student number. Just write what your student number is. Statement of the problem. What do you want to statistically find out? So here's the important thing. Normally speaking, when we collect data, it's because we want to answer a question. If we keep using the paper airplane example, the question is, I have 2 different paper airplanes. Which one of these will consistently fly further so that I could win a paper airplane competition? So the question is, which paper airplane should I use to win a competition where distance is the most important thing? So I'm going to be measuring length. I'm going to do it in meters with 2 decimal places. I will throw each plane 30 times and measure it, and therefore I've collected my data. And then I'll be able to analyze it and then say, yes, this plane is the best plane to use. So always start with a question. What question do you want to answer? Because the data you collect is supposed to help you answer that question. Response variable, what variable are you measuring? So for paper airplane is distance, so length in meters to 2 decimal places. As you can see, examples is time, length, money, weight, capacity, scores, phone data, kilojoules. So some people basically looked at, they went for a walk around their block 30 times or once a day for 30 days. And they got a friend of theirs to do it as well, a similar distance, and timed how long it took them to do it every single day. And basically, and they did it time with minutes and seconds. And so they did that for 30 days, and they sort of say, well, on who on average walks quicker? Who has a more consistent time? Length, paper airplanes, meters. Money, you could look at how much money you've been spending online. That's a bit messier. You could look at basically, I don't know, for money. There's something, sure. Weight, how heavy things are. Phone data was really interesting. I had one time some people look at basically how much phone data they use every day over 30 days. So not their own, like if they're connected to Wi-Fi, that still counts because they're using phone data. So basically over 30 days, how much do they use every day? And they get a friend to do it as well, so you can see who uses more phone data. Kilojoules, so energy burned when you go do exercises. The procedure you will follow to collect your data. So you explain to me how you're going to collect this data, because the procedure should be replicable. Basically, I should be able to follow your procedure and complete the same task and collect information the same way. So you have to write instructions clear enough so that the experiment could be done by somebody else. So, project report template. So again, student number, statement of the problem, objective of the experiment, date of the experiment. Tell me like what dates you collected the experiment on. It might be 1 day if it's a really simple thing like throwing a tennis ball. It might be over 30 days because you're doing a one a day thing. Keep in mind that if you do a 30-day thing, you're not going to leave yourself much time to analyze the data unless you use previous months, like for data. If you use phone data, you could use maybe previous months if it breaks it down like that. What are you measuring? What variables can you control? What variables do you have no control over? If you're throwing paper airplanes, you have no control over the wind. But you do have a control over the location. Do you want to do it inside or outside? If you do it inside, then there's no wind to contend with. However, are you going to find a big enough room to allow the planes to fly as far as they can? If you try a hallway, it might crash into the hallway and muck up the throw. So, a whole bunch of things going on that you need to take into consideration. And it's not bad if there's a bunch of uncontrolled variables, but this acknowledging them and listing them is really important because it shows you're thinking about it. Number of subjects or people involved in your investigation. So if it's just you because you're throwing 2 paper airplanes, or if you and another person, so you want to find out who throws paper airplanes better. You have one design for paper airplane, you go, well, who throws it better? The procedure you'll do to follow to collect your data, the results in a table. So analysis, so calculate mean, standard deviation, phi number summary, and IQR. So you're doing measure of center and measure of spread for basically, you're doing both. You're doing mean and standard deviation, and you're doing median and the IQR. Provide a diagram of your choice, so histogram and standard leaf plot and a box plot. Parallel box plot is going to be super important, so make sure you include it. There's a little link here that will allow you to draw a box plot very nicely. And then discuss the distribution, shape, location, and spread, and any outliers. Outliers are good to give you something to talk about, but if there's no outliers, also fun. Conclusions. Think back to your original question. You've collected all this data now, so basically answer the question. And then you can say, and then you use your analysis to support it. So think of it like you're making a statement and you have supporting arguments. I'm going to go with aeroplane B because even though it didn't have the longest distance, it was more consistent in how far it flew. It has a smaller range, it has a smaller standard deviation. You can go into details like that, just talk about it. Appendices if required, but And here is an example. So the statement was, I have 2 textbooks to trial as a resource for Year 12. I can only buy one of them. So I need to know which one should I purchase between textbook A and textbook B. So 2 classes will be chosen. The first classroom will have textbook A. The second class will have textbook B. At the end of the semester, both classes will complete a test on the same topic. And the results of the 2 classes will be collected and analysed and the data will be performed. So, day of the experiment is, yep. So the score will be out of 100%. I anticipate that people are going to get between 40% and 100%. I can control which classroom gets the textbook. I can control the topics that are covered, and I can control the exam questions. I cannot control student study habits, and I can't control if they get sick or not. Expected number of students. There were 2 classes. One has 25 students, and the other one has 28. So very similar. All students will be given the same exam and same amount of time to complete it. I will collect all the exams and mark them myself, so I know I'm being consistent with the marking. I will total the scores and record it in a spreadsheet against their name. I will organize back-to-back 7-leaf plot so I can compare the shape of the data. I will calculate mean and standard deviation, and I'll make parallel box plots. I'll be looking for any discrepancies, so if there are any outliers or weird things going on. So yeah. So, collected the data. Here's the raw data. Yay! It's nice and neat. It's not fancy. You can I just put it in a line. You can put it in a table. Analysis. Here's my back-to-back 7-leaf plot. So, Class A was spread all the way across rather evenly, where Class B really had this sort of big peaky shape there. Ooh. So much tighter spread, clear unimodal distribution. So that's good. Where this is scattered, Class A is scattered all over the shop. That's hard to analyze. Calculated the mean, standard deviation. Calculated phi number summary for both of them. There were no outliers. Here's my parallel box plot. And again, it sort of shows that Class B was much tighter together, whereas A was really spread out. So, my conclusions. The data indicates that the textbook used by Class B is a much better textbook to use. Despite the higher scores in Class A, the overall marks for the class vary too greatly. With a standard deviation of 25.1, 66% of the class will have a score between 23% and 83%. That's huge. That's like outside my expected. I anticipated 40% to 100%. This is 23 to 83, so that's... Ugh. The box plot for Class A supports this, showing 50% of the students are between 35 and 81. So 50% of the students, so in Class B, pretty much all the students in Class B are within the same range as 50% of Class A. So it's much better. Again, read the conclusions. Here are some links that I used. So here's my link for my box plot and histograms, which I didn't use, but it's not a bad thing to use. So that's the assignment and your normal appendices at the end. So that's the assignment. Think of a question you want to answer. Collect data on it. Tell me what you want, basically, so I can make sure that, yeah, that's a fantastic idea. Don't make it too hard, but be creative. If you want to do something of like throwing a tennis ball, that's fine. But I don't know, do something with time. Do something with kilojoules or phone data, or come up with something else and really impress me. Like, I love seeing every year people coming up with something I never even thought to collect data on. So it's up to you. Please the sooner you email your teacher with what you would like to collect data on, the sooner you can start the assignment and collect data. So don't delay on that. That's the first thing. You should stick out and get it done as quickly as you can. All right. Thank you very much.